Okay, let's move on to page 30. What if we have rational functions where we've got some function px divided by some function qx? Well, first up, if they have the same degree, you're going to get a horizontal asymptote. So if you're dividing a function by a function with the same degree, the remainder that you will get will be just a constant. So you will get a horizontal asymptote. You see here, if we've got a degree that is bigger on the top than the bottom, you're going to get an oblique linear asymptote. So that means a linear asymptote on an angle, maybe like that. And the last one there, if it's greater than the degree on the top by 2, we get some sort of quadratic asymptote where the function will work around an asymptote which is a quadratic function. So let's have a look at the example in your books on page 30. We've got y equals 2x squared minus 1 over x squared minus 1. Well, first up, it's actually often easier for these sorts of things to complete a polynomial division first. So think extension 1. Let's just do that in case you've forgotten a little bit. So 2x squared minus 1 on x squared minus 1. So we're going to divide 2x squared minus 1 divided by x squared minus 1. Well, we need 2 of those, so we need 2. 2 of that is 2x squared minus 2. Subtract, so negative 1 minus 2 is negative 1 plus 2, which is just 1. Okay, so what does that give us? Well, that means we've got a value y equals 2x squared minus 1 on x squared minus 1 is equal to 2 plus 1 on x squared minus 1. If you think about that, if you did 7 divided by 3, how many 3's going to 7? There's 2. So that's 2 3's are 6. What's left over is 1. You write it as 1/3. So you write it as 2 and 1/3. Okay, so the denominator there is just the 3. So the same here, x squared minus 1. Okay. So we're going to take it in a couple of steps. We're going to, first of all, sketch x squared minus 1. So that's easy. That's a parabola that is a positive shaped parabola that has dropped down by 1. So let's think about that. X squared minus 1 goes through here. Let's pick some points. That's 2. So that's 4 minus 1 is 3. So let's just plot some points here. We could do a 4 as well. So that's what? 16. That's too big. So 3. 9. 9 minus 1 is 8. Okay, so let's draw in a parabola there with this. You see, I've been on holiday, so I can't get the line to go through the point. Okay, next thing we're going to do is sketch 1 on x squared minus 1. So 1 on x squared minus 1. Well, what happens? We actually looked at this a couple of pages ago. It's a reciprocal function. So we said that the zeros of the function, so page 27, are vertical asymptotes. So that's the same as 1, what's the difference of 2 squares? X minus 1, x plus 1. The zeros are x is 1 and negative 1, so they are vertical asymptotes. So let's do this in green. We've got a vertical asymptote here. Let's make a green line. And we've got a vertical asymptote for negative 1. Okay, so these two vertical asymptotes for the function y equals 1 on x minus 1, x plus 1. We also saw that with reciprocal functions. I think we wrote there that somewhere. Let's have a look back at our pages. That's not the page. What did we write? We wrote that minimum and maximum turning points are inverted. So let's have a look at what we've got. That means that our little parabola here has a turning point, so that's going to be inverted. Still going through that that point there, so wow, I need to do a better job of doing this on a computer. Okay, what else? Well, we can do the other sides of it. So let's think about what happens to this function when x gets very large. We're just going to have a large value of y, aren't we? Oh, sorry, a very small value of y, because you've got a large number on the bottom times a large number. We're going to be heading out here somewhere. And we're going to be heading up here somewhere as x gets closer to 1. We're getting closer and closer to 0. Remember, we can't have not closer to 0. We're getting a very large number, but we can't get a value of 0 on the bottom. The same on the other side. It's a reflection on the other side. Oh, man. Okay, so that's as ugly as. Last step, we're going to sketch 2 plus. So remember, we're still sketching this function. We've done it by doing a division and then sketching this. These are equal, so the graphs are the same. Sketch y equals 2, so that just means that everything moves up by 2. So we now have a horizontal asymptote going across at x equals 2. This thing, this part of the curve is over here, and yet I know this is really rough. Over here, and this jumps up 2, so there are turning points now there. So we've got a parabola looking, that's not a parabola looking shape. Whoops. And finally we've got a parabola looking shape here. And we'll have a parabola looking shape here. Heading towards the asymptotes. Oh, I missed this one. Maybe I pressed undo too many times. Okay. Page 30, done. Okay, page 31. I'm going to leave that for you to have a go at as an exercise. Check back with me in the first week. If you've got questions, we can do it in class.